Okay, so we're looking for the area under the x-axis. So hit pause, copy the lesson objective down. Once you've done that, hit play, and we're going to look at an example. Okay, so in this example, we're tasked with finding the finite region bounded by the curve y equals x, brackets x minus 3, and the x-axis. Now, first things first, I've got to sketch what type of a curve it's going to be. It's if I expand that out, I get y equals x squared minus 3x. So it's going to be a happy quadratic. Sketching it out, looks like so. Y equals x brackets x minus 3. Now I need the coordinates. Where does this curve intersect with my x-axis? I need those coordinates if I'm going to integrate between the 2 points. Now how would I find that? I got y is equal to x times x minus 3. To find out where it intersects with the x-axis, I've got to solve that when y equals 0. So if y equals 0, then x times x minus 3 is equal to 0. So our solutions then are either x is equal to 0 or x is equal to 3. We can put those on our graph, 0 and 3. Let's just label the axes. Now I can find the area under the curve by integrating between 0 and 3. So if I integrate from 0 to 3, let's say area equals x times x minus 3 with respect to x. First things first, I've got to expand. So from 0 to 3 of x squared minus 3x with respect to x. I'm just going to write it here, give myself some room. So I want to integrate from 0 to 3 x squared minus 3x with respect to x. Let's put my brackets around it. That's going to be equal to, in square brackets now as I integrate, x cubed over 3, add 1, divide by the power, minus 3 over 2 x squared from 0 to 3. And to solve it, then I've got to sub for 3 and 0 and subtract. So I've got 3 cubed over 3 minus 3 over 2 times 3 squared. And I've got to subtract then 0 cubed over 3, which is 0 minus 2 over 3 times 0 squared, which is also 0. So I've got 27 over 3 minus 27 over 2. Simplifying, that gives me 9 minus 13 and a half. So my answer is minus 4 and a half. But since we're looking at an area, it's going to be positive, so the area is equal to 4.5 units. I know sometimes you prefer writing 4.5. Whenever we find the area under the x-axis rather, it's always going to be negative. Whenever we find the area above the x-axis, it's going to be positive. So we've got to take that into account, because sometimes we need to find the area that's both positive and negative, okay, as we do in the next example. So hit pause, copy this example down. Once you've done that, hit play, and we'll look at a further example. Okay, so here's our example. In the first instance, I've got to sketch the curve with the equation y equals x times x minus 1 times x plus 3. So let's have a quick sketch of what it would look like. Just a quick sketch, a brief sketch. There. I'll draw a proper diagram in a second. It's my x and that's my y. Now the solutions here where it crosses the x-axis, or y equals 0, are given by x is going to be equal to 0 when y equals 0, or x equals 1, or x equals minus 3. So any one of those. So if I plot that on here, let's put my minus 3 over here, the origin, and positive 1 here. Now looking at that curve, if you recall how to sketch a cubic curve, it's going to be x cubed, positive x cubed at the start, and then some more terms, x squared and so on. So just looking at the x cubed, as x tends to infinity, so does y. So it's going to be coming from a great height down there. And the same thing, as x tends to minus infinity, because it's x cubed, it tends to minus infinity, y also tends to minus infinity. So that's going to be from somewhere down here, hitting the curve. So we can sketch the other parts then, because it's cubic, and it's going to look like that. So that's what our curve looks like in general. And if we have a better diagram, that's what it's going to look like with our coordinates there, minus 3, the origin, and 1. That's our y-axis, and that's our x-axis. So that's part A, we sketched the curve. Second part, find the area bounded by the curve and the x-axis. Now as we said, when the curve is above the x-axis, we're going to get a positive result. When the curve is below the x-axis, we get a negative result. But we know because it's an area, it's got to be positive, and we can add the two together. So we've got to be careful how we find the area. If we were to try and do it from minus 3 to 1, there'd be some confusion, because the positive and negative would be subtracting some of the answer. So what we have to do then is we have to find the area first above the curve, and then find the area below the curve, and then add them together. So if we do the area above the curve in the first instance, so that's from minus 3 to 0, the integral of x times x minus 1 times x plus 3 with respect to x. If we integrate that, we get, well, let's expand the brackets in the first instance. So from minus 3 to 0 of x, and we're just going to do the double brackets first, times x squared plus 2x minus 3 with respect to x, and expanding in full, just take my equal signs over here, that's going to be equal to the integral of x cubed plus 2x squared minus 3x with respect to x. Brackets and limits, minus 3 to 0. Now I can integrate. That gives me x cubed over 4, oh sorry, add 1 to the power, so x to the power of 4 divided by 4, plus, add 1 to the power, so we get 2 over 3 x cubed, and add 1 to the power and divide, so minus 3 over 2 x squared. From minus 3 to 0. So, so now I need to substitute. I can see that this term, when I substitute for 0, this is going to give me 0, 0, and 0. Okay, so we don't always include it, but in this instance is our example. Let's do that. So when we substitute for 0, we get 0 cubed, sorry, 0 to the power of 4 over 4 plus 2 over 3 times 0 cubed. As you can see, because these terms are 0, we don't tend to include them. Minus 2 over 3 times 0 squared. So everything in the square brackets there is going to be equal to 0. Minus, what have we got? So we got minus 3 to the power of 4 all over 4 plus 2 over 3 of minus 3 cubed minus 3 over 2 times minus 3 squared. So that's going to be 0. So if I just partition this here, I can carry on. Oops. Oh, I don't know what happened there. And so I've got from here, that's going to be equal to minus, that's going to give me 81 over 4. It's positive. That's going to give me a negative there. So that's going to give me 3 times 3 is 9. But one of the 3's cancel, so it's going to give me 18. So minus 18. And that's going to give me then 9 times 3, 27 over 2. So minus 27 over 2. I am aware that you could chuck that in the calculator, and indeed you should in this exam. That gives me 81 over 4 minus times 4, so 72 over 4, and we double that, minus 52 over 4, and that, when we work that out, is minus 45 over 4, which is equal to, it's got 45 over 4. So that's the area between minus 3 and 0. Now I've got to find the second area. If you want to hit pause, copy this down, and I'm going to turn the page over because I haven't got room to do the other area. Okay. Good. Right. So now I want to find the area below the x-axis, or from 0 to 1. So I do the same, perform the same integral, but just my limits have changed. So from 0 to 1, x times x minus 1, x plus 3 with respect to x. When I expand that out, as I did before, that's going to be the integral from 0 to 1 of, what did we have before? X cubed plus 2x squared plus 3x, sorry, minus 3x with respect to x. When we integrate that, as we had before, we got x to the power of 4 over 4 plus 2 over 3 x cubed minus 3 over 2 x squared, and that's from 0 to 1. Okay. So we've got to sub in the figures. A bit easier if we're going from 1 to 0, or from 0 to 1. So that's going to be equal to a quarter plus 2 over 3 minus 3 over 2, and everything else in the other brackets is 0. Because 0 over 4 times 0 minus 0. So I'm just going to put a 0 there. I think that's more normal. Right. And working through that, what's our common denominator here? 12 times, so we've got 3 over 12 plus 8 over 12 minus times 6, 18 over 12. Work that out, should get minus 7 over 12. Which is what we expect. We get a negative, so the area is equal to 7 over 12 under the curve. So we can say the total area, got to add both of them together. We got 45 over 4 above. I've got to add 7 over 12. You can work that out on your calculator. I'm going to let you do that, and you should get 71 divided by 6. Okay. Good. So hit pause, copy the example down, and I've got a couple of questions for you. So your question is exercise 13F. I think question 1 It's quite useful because you sketch the curves. Moving on to question 2, just the 3 questions there. Question 3 is quite a good question to get through. Okay. Good luck.